What is up, everybody? See, we got people trickling in. Super excited about today's session. As you are joining, please throw in the chat where you're joining us from. Super curious to know. I'll be keeping an eye on the chat. Okay, I see we got Oakland in the house, the West Coast. We got 17 people so far. As you're joining, throw where you're coming from in the chat. Where are you currently? So we got Denver, Columbus, Ohio. We got Dallas, and we got the whole from all parts. Love it. We got New York, got the Bay. Awesome. All right, so as we're getting more and more people in, I actually want to get a gauge of what the room is like. So I'm gonna launch a quick poll. Are you a job-seeking software engineer? And we'll be sharing these results as well as they come in. We got Chicago. Man, I need some deep dish pizza, yo. I haven't had deep dish in a while. Awesome. All right, so here we have a gauge. We have majority yes, job-seeking software engineers. 15% are considering, 69% are yes, 8% no, 8% not yet. All right. I want to launch a second poll. How many years of experience do you have as a software engineer? Quick gauge of the room. All right, so we got 44% have 0 to 1 years, 1 year. 13% has 1 to 3. We got 13% at 3 to 6. 6 to 10 years, 6%. And then 25% 10 years plus. So that's awesome. And then quick poll 3. Would you like to apply to join our exclusive Outco Slack community consisting of job-seeking software engineers? It's a community where you could engage, ask questions, and network with other professionals in the space. All right, let that poll hang there as you guys go. I see hands being raised. Awesome. If you can just click the poll, whatever you think is best. So awesome. Thank you everybody for joining, for everybody who is trickling in. I see we're at 31 now. Great. So I want to quickly introduce myself. My name is John Brian Canella. I work as a career coach here at Outco, where I help software engineers through the job search lifecycle by helping them sharpen their behavioral interviewing skills. And I do this through one-on-one coaching, facilitation of classes during our 4-week career accelerator program. And at Outco, what we do is we empower job-seeking software engineers to earn the job of their dreams and ultimately create their own career success. And it's what makes me super excited to be here and to have you join us here today. I graduated from the New Jersey Institute of Technology with a degree in IT network security, and I did a minor in business. I mentioned I'm a career coach here at Outco. I also work as an IR consultant, incident response consultant at Mandiant, focusing on computer forensics and incident response. And prior to that, I was working at Cisco Systems as an IT engineer, also working within the cybersecurity space. So rundown of today's session, use the Q&A tab throughout. I'll try my best to answer your questions towards the end of the presentation, but for anything that you'd like to see live, feel free to use the chat to engage. The format is going to be I'm going to be going through the various interview stages, some hints, best practices, what software engineers typically go through when they're interviewing at Facebook. And obviously, all interviews may vary slightly. So these are just commonalities that we find in most interviews that you'd find at Facebook. And then towards the end of my presentation, I'm going to be handing it out to Curran, who is going to give a live walkthrough of a Facebook interview problem. So be on the lookout for that. Definitely want to stay towards the end for that. So I mentioned Outco. What is Outco? Outco is a software engineering career accelerator, and it was founded in 2015. So about 5 years now in business. We've been focusing on helping software engineers pass technical interviews, get career coaching, technical coaching, understand how to negotiate their salary. We do this during our 4-week career accelerator program, and our focus is on the CS fundamentals. And it's designed by people who work at top tech companies. We've helped over 2,000 software engineers from all seniority. So I love that during the poll, we had people coming in who have 0 to 1, we had 3 to 5, we had 10 plus even. So that's pretty much the demographic of those who join our program. So yeah, we've had people who join our program who have worked at the top tech companies, have attended the top schools, who've gone to, or they're self-taught, or they've gone through a boot camp, or they went through college, and they need that boost in order to get to the next step in their career. Our success is dependent on your success, so we actually put our money where our mouth is. 2 out of the 3 payment options, you don't actually pay until you get the job that you want. If you were to pursue partnering with us at Outco. So you're never forced to accept a job that you don't want. If you have like 10 offers, you don't have to like pay Outco until you accept the job that you actually want. And if you want to check us out as well, you can check us out on Yelp and see what other people have said about the Outco program. Awesome. A little bit more about Outco. The information that you're learning this from is compiled by engineers, recruiters, learning and development managers from Facebook, Uber, Amazon, Apple, and many others. And the content of this presentation is specifically tailored towards software engineers who are actively seeking for a job and are considering a job change. So this does span out to different jobs like machine learning, embedded. I know there's people that have a machine learning background, embedded systems engineers, DevOps. Regardless of which position you're interviewing for, you're always going to have those domain specific questions depending on the role. But definitely want to make sure that we clear this out, that it is mainly for software engineering roles. So yeah, without further ado, let's hop straight up into the interview process. So here's a brief overview of the interviewing process, the different stages. First stage is applying. So of course, you have to apply, take the first step in order to be considered. You'd be surprised, many don't. Some people feel like they're not qualified or they're scared to apply. So applying is one of actually the ways that you could get an opportunity at Facebook. Other ways that I've seen people get opportunities at Facebook is through LinkedIn. So you'll have like a recruiter reach out to you, you'll get a message, and we at Outco, we often get software engineers who are like, oh my God, like it's my dream come true, but I don't know if I'm ready for this. Like it's a big deal getting in somebody reaching out at a company like Facebook. So either applying directly on the site or being reached out to on LinkedIn is what we often see. Resume, so definitely need a strong resume to get in. Most people don't put that much of an effort into it, but this is something that at Outco we definitely help people with. Then there's the phone screen. So you'd be surprised not too many people prepare for the phone screen. They just they try to have a regular conversation as if they don't need to research the company first. So I'll talk a little bit about that, what you need to know in order to pass the phone screen. Then there is the text screen. In between, I'm gonna also talk about what you could do to maximize everything that comes into play when you're on a phone interview with Facebook. There's some tips there that you could do while engaging with the recruiter on the other side. So you have text screening. So usually it's one text screen at Facebook. You might have a second text screen if you're a borderline candidate. So be aware of that. You'll definitely want to stick around for the second half, like I mentioned, where we're going to have our technical coach, Karen, go through what a text screen looks like. And that's actually been put together by a former Facebook recruiter. So definitely want to stick around for that. Also on-site. So there's an on-site walkthrough with the lead engineer. It's usually a virtual whiteboarding environment where you're going to go through a whiteboard problem. And Facebook definitely sets the bar high for that. So that's another thing that we coach people on, how to whiteboard effectively. And then towards the end, I'm going to go over the community review. So you're not present for this part. A lot of people don't know what a community is or what the committee does, but we'll go over all those steps. The last thing in the whole process of interviewing at Facebook is the negotiation part. And it's beyond the scope of this presentation, negotiating salary. This is another thing that we go over at Outco. So if you're definitely interested in learning more about negotiations, I'm gonna later on launch a poll on learning more about like Outco as far as getting an info session and seeing the different things that we provide for the software engineers in our program. All right, so Facebook interview process. This is a simple outline, what the process looks like. You're gonna be applying, then there's phone, tech, onsite, and then the committee. So let's go straight into applying and what that looks like. All right, so first of all, it's very important to think about whether you're qualified to work at Facebook. I'm actually kind of curious to see where everybody here is at. How many of you feel like you'd be qualified to work at Facebook? Kind of, I'll keep an eye on the chat to see. I see yes. All right, that's awesome. Anybody else? We got a few yeses. I see a nope. Awesome. I see a few yes, more yeses than no. I'm a systems engineer, not software. Not sure this applies to me. Yeah. So the answer for are you qualified or not is probably, or you can be with some work. You'd be surprised. There's a lot of people who feel like they're not qualified, and that feeling alone is what disqualifies them. They're super qualified, but they don't have the confidence to even put the effort to apply. So definitely apply. It's usually a matter of whether we are or feel qualified, and gotta get out of the imposter syndrome mindset there. So when you apply, this is your chance to talk through the projects, your experience. You want to make sure that your passion is also communicated. That's what they're looking for as you're getting through the front door. Facebook is always hiring. That's just the fact. Regardless of if you're somebody who's 0 to 1 year, 2 to 3, 2 to 5, 10 plus, they're always hiring for all levels. So that's something to keep in mind. There's definitely a position out there for you. And I even just recently saw that Facebook is hiring 10,000 plus engineers, even during COVID. So Facebook right now, they're doing extremely well, even though the social distancing is happening. So those are also things to consider. Yeah, so big companies, they hire at all levels. And to get your foot in the door, there's the standard application process where you go to facebook.com/careers. Many people apply this way. They submit their resume via a public Facebook job board. There's over 60% of resumes are received this way. And it's actually easy for an application to get lost this way too, because you have so many people applying directly to the site that you often find yourself where you're applying to like almost like a black hole. So how do you make sure that you stand out and get your resume noticed? Those are things that we're going to talk about later on. But also knowing that when you're applying, there's also another way through the referral process. I'm sure some of you know, but the referrals should not be downplayed at all. Forming relationships with recruiters and software engineers on LinkedIn is super crucial for hiring your chances of obtaining an opportunity at Facebook. So it's referrals are when you have a resume that's actually submitted by a Facebook employee instead of you applying directly to the company. 30% of applications are done this way, and the result is a 3 times higher interview rate for software engineers. And it makes sense, right? Somebody internally referring somebody that holds weight to it, because you're more likely to trust somebody that's inside the company versus a random person applying on the site. So 60% plus hires are made through referrals. And that's just a statistic for the top tech companies on like Google, Facebook, etc. This is a slide here that talks about referrals in general. Reverse recruiting is the act of being your own recruiter, and it's a great way to get referrals. Reverse recruiting, like I mentioned, it's reaching out to people. You could use LinkedIn, email, forming those relationships in hope that it may later on turn into a potential interview at the company. So referrals have the highest return on investment. 82% of employers rated referrals above all other sources for generating the best return on investment. And it improves the quality of hires. So 88% of employers said that referrals are the #1 best source for above average applicants versus your random person who just applies online. And then the third statistic here is that referred candidates are 55% faster to hire compared with employees sourced through career sites. So another reason why developing these relationships are super crucial in order for us to get to where we want to go at Facebook. All right, so talked about applying. Now resume is the next step, and your resume matters at every single stage of the interviewing process with Facebook. So it's one of the biggest reasons why it's important to have a resume that's clear to read, easy to understand, something that illustrates your value. So you want to make sure that your resume stands out in comparison to other people who are applying. And even if you are able to answer all the questions right, if you don't have a very strong resume, as it's being passed along through the process, it might be not considered versus somebody else who has a strong resume and something that looks appealing. So yeah, definitely something to consider too, working on your resume there. So why even have a resume? The resume is here to save them time, right? Finding a great talent, great candidate like you. And then for you, it applies to every single stage. It allows you to showcase your value. So obviously, one of the reasons why we have a resume. The format, we want it to be one page, something that's easily scannable. Even if whether you have 10 plus years of experience or 1 year of experience for Facebook, for applying to Facebook, what they want is one page. So if you have a ton of experience, take all that, have that resume there for you, and then take the experience that you feel like is most relevant to that specific role, and then apply to that position. You want to make sure that you have keywords that are easily searchable, searching for tech, projects, any numbers, any performance ways that you were able to, any like metrics. So so ARM stands for action, results, and metrics. Those are things that you want to make sure are highlighted in your resume, because you're competing against hundreds of other engineers who are applying for this exact role that you're most likely applying to. So what's going to separate you from somebody else is how you were able to communicate the actions that you did, what were the results of those actions, and what were some key metrics that round that experience and actually show how you drive value in that organization. And here I'm going to show you an example. So here's an example resume. In the top, you see that they have education. And this is an example of somebody who came into the program and we were working with them. This is a typical resume that you'll find with somebody who, they just graduated from college. They have their resume up with their education at the top, and they have skills somewhere at the bottom. And, recruiters, they take an average of 6 to 7 seconds when they're looking at your resume. So if they're going to take if they're taking their time, 6 to 7 seconds of time to look at a resume because they have a whole pile waiting for them, and there's thousands of people applying to these roles, they want to see like how you drive value from the get-go. And education, of course, like if you're applying, that's already known that you have that education. So I put skills closer to the top where a recruiter can quickly see, okay, this aligns directly with the role that these skills align directly with the role that this individual is applying to. You don't want to be in a position where they focus too much on, the degree type and they skip past you. So those are things that we want to think about as we're applying. So yes, you want skills first, experience, education, and then projects. So that's what we suggest in your resume. And then of course, follow ARM, action, results, and metrics. And you're gonna be using ARM in your bullet points as you're working on your resume. So here's the same resume after we worked on it. And you can see at the top, we got skills. We also have, we have technical skills at the top. And then we mentioned proficient and also exposure to. So exposure to is something that I feel not too many people really put on there, but if you put exposure to, it allows you to put those keywords that you do have exposure to. And most times resumes are put through the machine, right? Where it's a tool that's used to look for keywords to see like which candidate has the best experience overall. So to make sure that we are seen by those systems that are in place to find the best resume, we want to make sure that we have all the keywords necessary. Maybe find those keywords that are on the job description that you have exposure to, and put it in your resume. Even if you don't have like 3 years or plus of experience in that role. So that's gonna definitely help you as if you're put through a scanner, for example. Qualifications of achievements, also another thing to highlight. So it's you want to make sure that the resume speaks, that shows the value that you provide in a bulleted form. So let's say I'm gonna just quickly go through this here. So we have a before and after. So before, we can see before using ARM, the action, results, and experience. So we have this candidate here says in the before, developed and deployed automation software for configuration testing of nationwide station racks, improving technician productivity by approximately 20%. And then after we worked with this individual, we changed it to make sure that we add, the amount of time, the amount of time that was actually saved by doing this. So we changed it to optimized manual config searches by web scraping configuration pages using Ruby on Rails, and the Corgiri, removing need for 800 plus hours of manual configuration searches. So here we were able to better communicate the amount of time that was saved and how we were able to really make an impact in that project. So those are things to make sure that you focus on as you are editing your resume and improving it. So here's just a side-to-side comparison of the resume. On the right, you could clearly see, like, if somebody's looking at from the top down really quick, you can see, okay, he or she has this technical experience, has exposure to this. They have education somewhere towards the middle. They have projects there listed. So those are all things that a recruiter is looking for as you are being considered for a potential role at Facebook. All right, so now they got your resume. They say, wow, like, this is amazing, this is great. Let's move this candidate forward to the phone screen. So phone screen, why do they do phone screen? The reason why they want to do the phone screen is because they want to see whether you or not you're a great fit. If they see the resume, they can see your experience, but they want to hear it from you. They want to make sure that you're not just putting anything on there. So this is the type, what type of vibe are you actually bringing to the team, to the culture? Are you somebody that would fit what they're looking for the job description? Are you somebody that I want to work with? And then for you, it's what factors your final decision as well. So during the phone screen, during the interview process, they're interviewing you, but you're also interviewing them. And those are also things to consider as you're interviewing, because it is a two-way street. And I mentioned fit. So this is the part where they assess whether you can do the job. Do you have the skills? Do you have the experience? What is your education? Your educational background? Are you able to learn on the spot? If I give you a problem, are you curious to continuing your learning, even though you've already got to this far? Do they see like leadership potential in you? Those are all things that they're considering. Are you somebody that I want to work with? What's your attitude? What is your communication style? What's your experience and history? So are you somebody that's coachable, right? Those are all things that are being considered during the interview. I mean, as I describe these things here, it could be common sense, but not too many people have these things on top of mind, right? Like the nerves come into play when you're in an interview. So before you go into an interview, make sure that you have these things in the back of your mind to make sure that they're properly being communicated, because that's what the interview is about, right? Showing how you add value. And if we can't show how we add value, then how could the person understand how we add value, right? Like if we can't properly communicate that, we don't have the confidence to show it and to demonstrate it, then the interview is going to go downhill. So also tone of voice is huge as well. So make sure that you're, if you're standing up straight, like shoulders up, having writing things down as the person that is asking you questions, and doing follow-up questions as well, being engaging, sounding interested. Little things like that also go a long way. So the analysis formula. So here's the different percentages of what interview consists of. So there's coding and analytical skills questions. So trying to get your tech competence, that's about 25%. Your communication skills or your general cognitive ability, that's another 25%. Leadership potential, desire for future impact. What is their return on their investment? Are you somebody that could grow within the organization, maybe develop something that they don't currently have? And of course, culture fit. And of course, since we're all human, there are biases that are in play. So those are things to keep in mind, but at the same time, don't let that be a limiting factor. You want to make sure that you're bringing your full self to the interview, because when you're hired, you want to make sure that you can be your full self at the workplace. So things about like culture fit, I know for Facebook, they instead of instead of users, they use the term like people. So knowing little things like that, understanding the values of the company, following the ABCs, like the ABC stand for always be communicating. So as you're going through a problem, making sure that you're communicating your thought process. That even if you during an interview, even if you don't come to the full solution, they at least know how you're thinking. And being able to communicate is oftentimes the biggest differentiator here on what separates one software engineer from the other, because two can be very, very technical. And we want to make sure that we're not only just technical, but are able to communicate throughout the whole problem or the whole question that's being asked. So they're trying to figure out, do we want to work with you? Do your values align with the company's values? Do you have the people and communication skills, like I mentioned there? Awesome. All right, so typical format for the phone screen. So expect it to be about a 15 to 30-minute phone call initially. It's going to be non-technical, where they're trying to get to know you. The content of what to expect. So you'll probably be asked something like, what percentage of your job right now involves coding? And this is your chance to talk about what you're currently working on. So what percentage of your job actually involves? And let's say you're not spending your whole day coding right now, even if you're working on projects outside of work. If you're not, let's say you're not working on any projects right now outside of that are extremely like focused into coding. As soon as you get off this presentation, you can start working on a project and have that be something that you continue to talk about for the future. So those are things to know. You'll be asked something like, tell me about your most recent project. Why are you the right person for this job? What's the hardest problem that you solved? Those are all questions that to expect. And this is your chance to use the STAR method as you're answering these questions: situation, task, action, and result. So this is where they're trying to get a gauge of what your experiences are, how passionate you are about the things that you're currently doing, and if you'd be a good fit for the company. So you want to make sure that you're flipping negative questions into a positive. So if, let's say, you're asked, tell me about a time where you've had multiple deliverables, how did you prioritize and deliver? Making sure that you're telling a complete story. And if there's ever any time, sometimes when we're applying to new jobs, it could be because you're just having like a horrible experience where you currently are. So we never want to badmouth people at our company or a project that we're working on. We always want to spin things in a positive light, talk about the things that we've learned and how we grew from that experience. So, like, for example, what did you dislike about having a manager? Those are some questions that you could be asked, and what they're trying to see if you would actually say something that's really negative about your manager. And the right way to answer this is to mention that, of course, like there are instances where where things are not always 100%, like things are not always 100%, like where you can disagree on things, but you always made sure that everything was always left out on a positive note. And you could describe a situation where you've been in that scenario. Tell me about a time that you've had a conflict at work, right? You could always, they're also trying to see if you'd make the company look bad as well. Why do you want to work here? So this is another type of question where you can say, man, I just like hate where I am right now. Where I am sucks. I definitely just want to work at Facebook because it's a big company and I believe I can add value. That's like a horrible way to answer that question. Always make sure that why do you want to work here? Always make sure that you highlight the positives of that company. Talk about the culture, the mission, the vision, and how inspiring it is to work at a place where you could add value. and provide value to many people around the world. Which of the following is not a reference type? That's another type of question that you'll get. All right, continuing on. So for the Facebook phone screen, you also get to the point where they're gonna screen your performance, and they're gonna be looking at your resume. They're gonna see if you stand out from competing applicants. Are there any keywords that are on there? Were you able to talk about? Did they have any projects, any relevant projects experiences? The numbers portion. They're also going to look at ARM, so action, results, and metrics, like I mentioned before. And those are all things that are going to be considered as you are moving forward to the next phase of the interview. So maximizing the phone screen is super important. So make sure to pay attention to this part. Not too many people take advantage of maximizing everything that they could do during the phone screen. Remember, your resume is being considered throughout every single part of the interviewing process. So what is the mindset of a recruiter? What does a recruiter want to do? Kind of curious to see what you guys think about this question here. What is, like, why is the recruiter even in the picture? Let me see in the chat. What do you guys say? Like, what does a recruiter want to do here when they're speaking to you? So there's many different ways to look at a recruiter. You know, you can look at them as a hurdle, right? Somebody who's against you, maybe an adversary. I see here on the chat, help me to find best possible position. Yep. See if you're a good personality fit. Make sure they hire the right candidate. Tech fit comes later on in the person. Got you. Yeah. All great. Help you succeed in the process. Awesome. Yeah. So those are all great. Yeah. So you can look at the recruiter as either somebody who's against you, right? Somebody that you have to like fight with to get the job, or you could look at them as your advocate, somebody who's on your side, who you could ask questions to, right? They're human. They're a future teammate, right? If you wind up being hired, they're somebody who is helping you get to where you want to go. So how we see recruiters oftentimes during the interview process affects how well that we do during the interview process. If we feel that this person is against us, then we might not bring our best self to the conversation. So they want to get you hired, and they have open recs that they want to meet, and then there's numbers that they need to meet. So that's one of the reasons that they're talking to you, to make sure that they can hire the best candidate for the position. So they want to set you up for success, and Facebook does an awesome job at this. And things that you could ask them are like, you know, do you have resources to help me out? You could ask the recruiter during the phone screen. You can ask them, you know, do you have any resources that you can help me out as I prepare for this interview? Can you help me plan for what will help me, you know, make the best impression on the manager or the interview, or who's going to be interviewing me? You could ask for insight to the team. So even if you've applied in the past for a position, you could see if they could even pull up something in the record to see if there's anything that you can improve on from the past. If you've interviewed there in the past, you could ask for some feedback. So what can I do to make sure that I come in and hit this interview out of the ballpark? And what can I do to make sure that you fill this role that you are looking to fill for the software engineering role? So the recruiter is your advocate. Look at them as such, and you will definitely go far. All right, so now we're going to the Facebook technical screen. So for the Facebook technical screen, the format is usually around 45 minutes. Usually a hard stop around there. The code must compile. Remember, the code must compile at the end. There's going to be a brief intro, then live coding with 2 problems. The first is going to be an easy warm-up problem, about 15 minutes, and then you're going to have the remaining time for the second problem. So what this consists of is a data structure and algorithm questions. So the computer science fundamentals, those are the types of questions that you're going to be asked. See how well you perform during that that interviewing question. Also, since now everything is virtual, you're probably going to use something like CoderPad to write your code. So there's going to be a demo later on illustrating what a typical coding question is going to look like. You're going to be provided minimal hints. So you're going to be working, but make sure that as you work, you're also speaking through, always be communicating, speaking through what you are working towards. And then there's no compiling here, so you're going to basically be writing code on there. And then syntax highlighting, also making sure that you are taking time to highlight your syntax there. All right, so intro question. An intro question can be something like, tell me something that you are working on right now. How much coding are you doing? And what percentage of the time? What is your strongest coding language? Talk about purpose and complexity of the language, and also trying to figure out your approach to solving a problem. And is your approach the best approach to making sure that the problem is solved efficiently? Moving on, more examples. So you'll probably be asked also questions like, given a list of integers, find the frequency of the target. Questions like this, and the interviewing style can vary for sure, depending on the position and the team. You don't want to rush into coding. You want to speak through the problem, build rapport with the person on the other side, knowing that they're also human too. You'll also have a diagramming question, and we're gonna have a walkthrough as well for that. Determine constraints and edge cases as you are going through your answering your question, and then also provide key insights of what stood out to you as you were going through the problem. And again, if you aren't able to fully answer the question, making sure that you highlight your thought process. Your code must compile at the 45-minute mark. So that's what they are looking at the end. So another thing to consider there. For the technical questions, focusing on performance, so time and space complexity, start with the best solution that comes to mind. Again, always be communicating. I mentioned this multiple times. You want to make sure that you're speaking throughout as you're going through the problem itself. Iterate from each solution towards better performance. Talk about key insights. Do you recognize the optimal solution? And things that they're going to look at are frequency count, sliding window, and graphs. There's different ways to solve the problem. So finding the best way of solving that problem is what they're trying to find here. When it finally comes to scoring, what they're going to look at are they're going to be grading you on a scale of 1 to 4. So are you somebody who's are they highly confident that you're going to pass, or are they highly confident that you are somebody who failed the interview? So they're gonna do it's within these 4. So absolutely, highly confident, average, or low confidence. And they're gonna say, yeah, like I'm highly confident that this person is a fail, highly confident that this person is a pass, or they could say something like, it's average fail, average pass, or I have a low confidence that this person is a fail or a pass. So for borderline, if let's say you're a referral and you're kind of like borderline, this is one of those where if you are a referral, somebody inside could even vouch for you. If you've developed a good relationship with your recruiter and the recruiter sees a lot of potential in you, they could also vouch for you as to why they believe that you're a great candidate. So it's one of those reasons why to think of the recruiter as your advocate, and why you should develop those relationships with software engineers through reverse recruiting on LinkedIn. All right, so scoring is used both for the on-site and for the tech screen. So Facebook tech screen, they go to for the decision phase. They're gonna see, did your code actually compile? Was it optimized? Were you easy to communicate with? For the phone screen, they're gonna see, how did this person perform relative to others? How was the resume? Was it one page? Am I able to see from the very top, like the types of skills that this person has? And were you able to stand out from other competing applicants who were competing for this same exact role? So again, making sure that you work on your resume, making sure that your code compiles and that you're able to communicate and talk through the interviewing process. So the next phase is the Facebook onsite. So the format for the Facebook onsite is usually 5 different 45 to 60-minute interviews with a 1-hour lunch break somewhere in between. Sometimes it's one system design question, and system design questions are given to see where your fit is, like your level setting. So expect data structures and algorithms, but if you get a system design question, that's usually given to see if you're more of a mid-level to senior level candidate. Typically, it's going to be on a whiteboard or a coder pad. You can pseudocode during the Facebook onsite as a crutch, but preferably you don't. So I mentioned 4 coding questions, data structure and algorithms, and 1 system design. Yeah, and depending on the role, if it's more of like a front-end role or back-end role, it may be sprinkled. There may be domain-specific questions that are sprinkled throughout the interviewing process. So make sure to study on that. And yeah, the data structure and algorithm is similar to the tech screening side. For system design, the system design is where you are getting leveled, and they want to this is where you want to demonstrate your knowledge here. So if you are going for that high level role, make sure that you study on your different types of system design questions. Questions akin to movie ticket processing systems, parking lot systems. If you're a new grad, they typically won't ask you a system design question. So don't worry if you're somebody who's like 0 to 1 to 2 years. All right, so hopping on to the Facebook onsite decision to move to committee. So this is where they evaluate your onsite performance. They look at your analytical skills, your coding skills, communication, and your experience. And they're gonna see how well you did during the technical screen, how well you did during the phone screen, and of course your resume. So again, your resume is being considered all throughout. No feedback is usually given here if you are rejected, so don't expect it most of the time. You could ask for feedback if you'd like, but if you don't, it's just if you don't receive any, that's just normal to not receive feedback there. All right, so for the Facebook hiring committee, the Facebook hiring committee, what they are set in place is to figure out, are you somebody that they're going to give an offer to, or are they going to reject? They're going to look at your on-site performance and your score, how well you did during the technical screen performance, the phone screen data that's been gathered, looking at your resume, if you were an internal referral. Again, Facebook referrals, they matter a ton. So try to get a referral in, and it'll increase your chances of being considered for the position. Another reason to develop those good relationships. So you might get feedback at this point from the hiring committee, depending on the recruiter. And if you haven't heard back, definitely make sure to reach out to the recruiter to get an understanding of where you are. All right, so that is pretty much the Facebook interviewing process in a nutshell. What the stages are, we talked about applying, we mentioned the resume, which is super important, the Facebook coaching call, making sure that we take advantage of this, the phone screen, preparing for the phone screen, doing our homework on the company, looking at the website, networking with other professionals at the company. We talked about the tech screen, the on-site, and the committee review. So negotiation as well, those are things that we can talk a little bit more later on if you decide to go through the 4-week career accelerator program here with Outco. All right, so as we go on to our break, I want to launch another poll to see which dates work for you to get an info session. So which days are you available to join us actually for a live Outco info session and to learn more about the Outco program? Also, see a lot of votes trickling in. If you're interested, please pick your date in the poll. All right, so I do want to leave you guys with some things here. I'll give you guys a 5-minute break as well. So it's 7:22 on the West Coast. So if you guys could come back at 7:27, that would be great. I'll see you back here. In the chat, I'm going to be posting a bunch of different links here that you could utilize to practice your interviewing. So posted a bunch of links here for you. So feel free to come back. 7:26. You guys are back. All right, so the next step in this, the next phase of the presentation, I'm gonna hand it over to Karen, who's gonna go over what a technical question at Facebook looks like. So I'm gonna have Karen take it away.
All right, thanks, John. Appreciate it. Just a minute, just a second. Let me get some of my resources a bit more prepared and we can get started. While I'm doing that, I just want to introduce myself. My name is Karan. I am one of the technical instructors and software engineers at Outco. So I do a lot of the kinds of problems and demonstrations for the kinds of problems that you're going to see in just a second for a lot of our students, a lot of our clients as they're preparing for their interviews. Okay. All right.
Looking in the chat here, it says an interview. Is there an interview session for IT engineers or systems engineers? So I'd say typically for IT engineer, I think IT engineer is a very it's a title that, depending on the role, depending on the team or the company, it can vary, like what the responsibilities are. There's some IT engineers that are very like they code a lot. So if the IT engineering role is specific, there's a lot of coding involved. I'd say definitely attend the info session to learn more. For systems engineer, that's kind of like borderline, depending on how much you're going to be using your coding skills there. So I'd say regardless, attend an info session to learn more about if Outco is a good fit for you.
Cool. Thanks, John.
Yep.
Okay, so what I'm going to be doing today is that I'm going to be doing a demonstration of an example of a kind of algorithmic problem that you will see in a technical screen. So we're not necessarily going to be getting into the system design components. This is what you'd be seeing maybe right out of the gate in like an initial technical screen when you're working with Facebook. So there's a couple of things that John mentioned earlier that I want to make sure that all of you are quite aware of when it comes to the process of approaching any problem. Even if it seems simplistic or trivial with the approach that you're working with, you want to make sure that you're solving the right problem and that you're fully understanding what you're doing before you actually dive into the work on the problem itself. So that's why I have listed at the top over here these 3 steps that you really should keep in mind in your problem solving process to make sure that you have foundations to work on and move forward with. So understanding, you need to fully understand the problem that you're given. As you're working on your understanding of the problem, gathering information about what exactly is going to be specifically your inputs and outputs, right? Are you dealing with integers as your inputs and outputs? Are you having arrays? You know, like what are the data types? Those kinds of things. Trivial, but mention it, right? If you forget this kind of information and then you don't actually return what you should be returning properly, or think about your inputs properly, you know, it's like a simple thing that could make everything above as you move forward sort of crumble. Okay, so form an understanding. Find out what your inputs and outputs, of course, are going to be like very clearly from your interviewer. If they don't explicitly give you this information, like you're going to be given a 2D array and just a single integer as an output. Okay, then what you want to make sure that you do is, of course, try multiple examples. So example 1, see what you could do with this particular example. Does it make sense what your understanding of the problem is? Try other examples as well, right? And then, of course, ask for any constraints that you can about the problem, or at least try to discern the constraints of what you're going to be working with. Okay, so let's actually get into the discussion of this particular problem. So we are given a problem where we're trying to find the length of the shortest path in a matrix from the top left corner of that matrix to the bottom right corner. This is the only information that we're given right here. And also we are given the bit that there are boundaries with which we cannot necessarily pass, walls that are going to be defined by ones that we might see in the matrix and zeros where we can actually do the path itself that we want to travel. Okay, we're not given any sense of like directions that we want to take, so we can start to maybe think about some assumptions that we might make. So directions, let's say, of course, we want to consider the possibility of being able to move right and down. And this is where I'm also like considering the step of diagramming, right? I'm walking into the problem, I'm seeing what I'm going to be given, and trying to take those steps to get through it. So of course, we're going to try and move right and down towards our destination. So let's see. If I try to move down this way, what I'm going to do is just mark this node that I'm looking at, this point in the matrix, as a 1, just to show that like I've gone down this path, right? So I'm going down, I'm going right. Okay, but I happen to hit some walls over here. So maybe I can also consider the fact that I'm not just constrained to just moving logically as you would think, right and down towards my destination, but I can also consider the possibility of moving up and left as well. So basically, in these this single variable directionality or something like that, I realized actually there's also one bit of information that I didn't explicitly receive from or provide over here, but it's also that we could only move in one direction at a time. So we're going to move up, down, left, and right to get towards our destination. And we can sort of walk through it and see what makes sense, right? How is it that we get an output of 8 for something like this? If I just walk through my diagram over here, this is something that you're going to be doing in an interview, right? When you're working with an interviewer, you're not going to be able to draw on a sheet of paper and do something like that. So you need to be comfortable with the concept of actually ASCII diagramming when you're doing things. So can you show the interviewer what your thought process is by actually typing out some of the steps that you're doing in a diagrammatic type of fashion? So that's what I'm doing here. I'm doing my walkthrough through this matrix, and I'm seeing, okay, I did 1, 2, 3, 4, 5, 6, 7, 8. Of course, if I go the other path, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so there's 10 steps going the other route. So we can clearly see what happens to be the shortest path to get towards our destination. And that's what we can visually see in terms of actually trying to solve the problem. So this is where maybe the next step that we want to take in our diagramming thought process is to actually see how we can translate that into a series of steps. So I'm going to kind of combine this idea of code into kind of the pseudocode aspect of things, you know, basically listing out or trying to diagram while talking about the steps that I want to take to solve this problem. First thing I'm going to do is think like, okay, I had this path that I was choosing that was defined by a row column combination, and I can go in 4 different directions. So maybe let me try and define those different directions. This is the ASCII diagramming that you can do. It might seem tedious to do something like this, but this is something that, you know, will help visualize what's going on for you and your interviewer as you're walking through something like this. Actually, let me take a step back on one thing. I mentioned constraints. I didn't explicitly talk about that. By the way, if anybody has any questions as I'm walking through this, feel free to put some in the chat. I'll try and make sure that I can pay attention to those questions as we're walking through this. So some of the constraints, I'd say, if we want to just quickly define that before I get back to my diagram. Well, at a minimum, I know that in order to actually really find a path through the matrix in any fashion whatsoever, I'm probably going to end up going through every single node in this matrix. So that's going to probably be at least a lower bound of what I might consider as the information that I'm going to work with. So maybe for time itself, we can look at the boundaries, or really, sorry, the number of elements in our matrix, and consider that as a potential time at a minimum that we might take. Space, I'm also going to say that we could be dealing with something similar, because maybe we might need to keep track of where we are and what distance we've gotten to up until a certain point as we're going through this matrix. So I don't know, maybe we could find a way to do it in constant, but I don't necessarily see that. So we have a list of some constraints that we're sort of assuming and working along with. You may not necessarily be given this by the interviewer. Oftentimes, even if you ask for it, they're not going to give you this. So you need to reason at least some idea of it in the back of your head. Okay, so we have 4 different directions that we're going to consider taking. All right, so if I'm going to move right, what I'm going to do is increment my column, right? So I'm going to be starting up here, and I might go that particular direction. All right, let's actually use a smaller example. So what I'm going to do is just create a matrix that's going to be just 4 elements, and we're going to have one wall in this. It's going to be right there. Okay, so we have a smaller matrix. What I'm going to do is sort of diagram out my thought process and path of walking through this matrix. I'll start off at the top index, which is going to be at the, let's write out some of these coordinates too, because I think that could be helpful. So we say we have something like this. Okay, 0. So we're going to have row 0, column 0, and we're going to move right, which just means that I'm going to be at this point right over here. Okay, that's one direction. The next direction is, of course, moving down, which is going to be incrementing my rows. Or what I could consider is trying to go up, right? That's going to be decrementing my rows. Or I can consider trying to go left, which is going to be decrementing my column variable or something like this. Now, as we sort of do this kind of walkthrough, we can see that there's some conditions in which we obviously cannot go along a particular path, right? You're going to get an out of bounds index type of error. So you want to make sure that if you, with the tools that you're employing, that you consider these conditions while you're getting towards your destination. So there's a couple of different things. I'm going to define these as base cases. There's going to be, actually, let's see, there's going to be a few. So I'll number them here. We'll consider out of bounds. It's probably going to be one of the first things that you handle, so you don't deal with any null pointer exceptions when you're actually dealing with a negative index axis, right? Negative indexes are not going to exist. The other things that you might consider is, am I hitting a wall, right? That was the other part of the problem. If we have a 1, we're not allowed to go to that particular direction. So let's explicitly define that we'll hit a wall. Okay, so that's where we might consider stopping. So we're not going to consider going down any of these 3 paths over here for this example right here. All right, so what I'm going to do is start writing out possible paths that I might take from this one, this path over here. So it's going to be right here. Okay, so I can do a couple of things. Again, I'm going to write all these out. Move right, move down, move up. What else? Oops, let's get to the end. Or what we can do is move left. Okay. Now, you can take out the negatives. Looks like we have another condition over here. All right. So another point at which we might have stopped, we can just go ahead and define that, right? We could say we have a destination reached at that point. That's what we're looking for, right? We're trying to see we're trying to find a path to actually get towards our destination. And once we've reached there, there's no reason to really go anymore along this pathway. We're starting from 0, 0, go 0, 1, 1, 1. There's, you're not going to make any more movements, also because it's not even possible from an index perspective. So that's another base case we'll consider. Then the negative situation is another we can consider. Another out of bounds condition. So instead of going negative, of course, we'll go greater than our rows and column combination. But then there's one last one that happens to pop up here, this 0, 0. So this should tell you another thing, right? We don't want to necessarily go back to the particular location that we've come from if we're going down one given pathway. Otherwise, we're just going to get into this loop of going 0, 0, 0, 1, 0, 0, 0, 1. The circular endless loop of possibilities. So we want to make sure that we have this way of marking things visited. And I hope all of you understood in the process of trying to walk through my diagram. That's what I was sort of demonstrating. Basically, this idea of marking where I visited as a place that I have visited in some form. What I did when I was doing that was just changing whatever value I got in the matrix to a 1 in that particular condition. Okay, so hit a wall or visited is going to be something that I'm going to modify for this particular base case that I'm looking at here. Okay, so I have 3 different base cases that happen to make sense. And this looks like we will take paths to get to our destination. But we want to make sure we keep in scope what we initially said that we're looking for with this problem, which was itself trying to find the shortest path in the matrix. So let's make sure that we actually find a way of keeping track of that, right? If we're going to go down a path, let's actually keep track in state in each part of this path. the distance, or really the length of the path that we happen to have traversed so far. So I'll say at the very starting point, I have a length of 1 in my path. So I'm going to add that as one of the parameters that I'm going to consider in my traversal steps, right? And I'll also add it onto all of these other things right here. So not 1, sorry, we're going to have 2 here, right? We're at the second level away from our destination, of our origin, sorry. Okay. A little bit of spacing issues, but not to worry on something like this. And we have 3 over here. So we'll basically consider what distance we've traveled so far and propagate that down as we're going through these subsequent levels. Okay, so once we actually get to the end, that's where we've actually seen that we can actually keep track of the distance that we've traveled along this particular path. Now, I'll mention one thing, right? This is a simple matrix. So this particular solution is still not necessarily complete. And it's also potentially going to be problematic if we really think about it, right? We want to not necessarily consider doing so much worse than this kind of time when we're looking at something like this. But if we try to do this kind of thing, I might end up in a scenario, first of all, 2 things, right? Maybe let's instead of going down that path, let's go down the other path. So I'll go down this one. All right, I'll go over here. Okay, I'll get towards my destination, and I can go ahead and say like, okay, the distance from a global perspective, the minimum encountered so far is a distance of 10. Okay, let's go ahead and explore the other paths. First things first, 1, there's another step that we need to account for. When we're rolling back up, we need to make sure we also have a way of unmarking a place that we've gone as visited. So basically at the end of each of these traversal steps, I'm going to say, okay, I've traversed everything I need to have done from this point. So I'm going to unwind and backtrack from this possibility. But the thing is, once we backtrack at this point over here, I have sort of a dumb algorithm that's going to attempt to go right, down, up, and left. This is going to attempt, so we might be right here. This is going to attempt to actually go up and then left, which is completely useless for us, right? If we have this automated sort of methodology of traversing in a dumb way without actually trying to get towards our destination, we don't have, first of all, any way of really optimizing on that in this methodology, because we don't know when we're going to reach our destination by any means except for based on these base cases. And this is going to get us traversing through the entire matrix, through all of the nodes that we're given, more than O of n times n by a long shot. It's going to be actually exponential with this particular kind of approach, which is kind of a pretty bad deal. Actually, if we're going to look at the analysis of doing this particular kind of approach, which, by the way, if we're going to define this, is a DFS approach, this is going to be something like O of 3 to the power of, we'll say, m times n, right? Because we have the possibility of all the nodes in the matrix being traversed, and it's an exponential time complexity because, well, we're going to have, I think for a lot of people, you might actually think it's going to be 4. So I'll talk about it from that standpoint for a second. So because we have 4 different branches, and as a heuristic, when we're thinking about like this brute force exploration process, a lot of times when we're doing something like this, using recursion probably is a tool for doing DFS, or even using a stack. It doesn't really matter. You're going to still end up doing the same kind of node traversals. We're going to have 4 different branches, and the total number of nodes that we might traverse in a worst case large input scenario is going to be exponential with 4 to the power of m times n, except it would really actually be 3. And the reason why I'm saying it's 3 is because when we handle the scene condition scenario, we're not necessarily going to go in one of the 4 routes that we're given. We're never going to go back on that route ever. So it's really just 3 routes that we're traversing each time, but it's still exponential, and that's not something we want to deal with. Now, space that we're working with, well, since I talked about using recursion for something like this, or even if you did this iteratively, we're just dealing with stack space, which is going to be at most the traversing all of the nodes in the matrix and the stack space is going to be as deep as the level of this recursive tree that I've sort of ASCII diagrammed out over here. So space isn't going to be bad. At least it falls within our constraints that we're looking for. But this is where we want to start thinking about tackling this problem with maybe a different kind of approach. And that is going to be considering actually a BFS type of approach, right? You wouldn't necessarily think, if this isn't as familiar to you, to consider using just another kind of similar or simple traversal algorithm to actually keep track of distance as we're going along the way, right? And the way that there's a rationale for doing BFS. If you don't understand, first of all, just to make sure that we're clear about what DFS is, this is a depth first search, right? This is depth first search. I'm going as deep as I possibly can down one particular route within my data structure, whether it's going to be in a matrix form or a tree-based form or something like that. And taking the depths, and hence the terminology of a depth first search. Now with the breadth first search, or BFS, it's going to be breadth first search. Doing something like this. I'm going to be doing kind of like a shotgun approach, like at any given node, I'm just going to do a spread from that given point, right? The distance so far at that given point based on the information that happened to come before it, but not just along one path, but we'll start from this point. And maybe I'm going to make a copy of this because I'm going to need this later. So let's take this example a little bit further down, right? I'm going to go over here, start off labeling this as, distance of 1 or length of 1 so far. And then I'm going to consider the children, or basically the places that I can traverse from here. There's 2 that I can go. So if I'm going to do a breadth first search, I'm going to consider everything in the level that comes after this one. And the level that comes after this one is going to be at this point over here and at this point over here, right? I can move right from this point over here, or I can move down from this point over here. If you want to think about this maybe in terms of a graph perspective, let's say that we had a graph that looks something like this. Okay, I'm going to try and do my best to draw this out. Okay, so I have something like this, and see, we do this. Okay. All right. If I'm going to do a breadth first search, what's going to happen is first I'll consider this first level that I'm working with here. Then I'll consider this next level of nodes that I'm working with here. So B and D will be processed next, right? In sequence, using a queue data structure of sorts. Then C and E will be processed next. And using this sort of methodology of this sort of shotgun spread type of approach, we can say that, like, for this given level, it's a distance of 2 so far. For this given level, it's a distance of 3 so far. So when we actually finally happen to reach our destination, the first time which our destination appears is going to be the shortest path that we happen to get there, right? And let me demonstrate this further as I'm working with this diagram. So I'll do 3, then 4 at this level over here. Hold on. I'm going to admit, I don't particularly like ASCII diagramming so much. So you have to do all this clicking and highlighting type of thing, but it is what we are given, right? We are all remotely interviewing, so you have to deal with this sort of scenario where you can express yourself in this kind of way. It's limited tools. But okay, so I filled out distances as I'm doing a breadth first traversal through this matrix. And as we could see, first of all, there is a path to actually go from here to here if we wanted to, right? This could end up being a 9 and this could end up being a 10. But since I was just doing this spread, the first time I happen to reach my destination, of course, it's going to be the first time that this distance traveled so far, once we reach there, that is going to be our minimum distance, because by design, we have taken the shortest path. So this is something to understand, not even just with the matrix, but just the concept of having an unweighted graph. Your tool to try to do a shortest path traversal through that graph in an unweighted graph or unweighted undirected graph is going to be doing a breadth first search kind of thing. Okay, so this is what we're going to be attempting to do instead. And the methodology that we're going to approach doing something like this, we're not going to use recursion. And the benefit of doing this is also that this actually gets us to only traverse the matrix once. Notice how, as I was going through the nodes, I was just marking them based on the previous node that I might have come from. And I only filled up the matrix once, right? You didn't see me walking all the way through one direction, then unwinding, walking down in another direction, unwinding. So visually, you can see this advantage of the time complexity, which is another reason why it helps to just diagram these things out as you're working through your thought process. So time actually ends up being O of n times n, and space to actually, let's see, it is going to be m times n. Because in order to actually do breadth first search, we need to use a queue of sorts. So I'm going to represent this sort of queue just like this. I'm just going to have something like this. And I'm going to have a series of a little bit of information that I'm going to pop onto the queue, which is going to be the row that I happen to be on and the path so far at that particular row. Now, what I'll do is I'll pop off this row, right? So I'll go ahead and take off this thing from the front of the data structure. This is a queue data structure, right? It's going to be first in, first out type of thing, right? So this is what happens to be at the front of the queue. You put it on the queue, and once we get started with using our queue, we'll pop off whatever happens to be at the front. Then we'll go ahead and put in the information about the children, right? That's going to be the right, left, up, down possibilities that we're going to be given. Okay, I'm not going to talk about everything. I'm just going to put in whatever happens to be possible, right? So we know that we can move right. So that's going to be incrementing my row, right? And I'm also going to put the distance that I will have to travel to get to that point. And that's going to be based on this parameter right here. Let's get a little bit more explicit about this so that, I'm just not typing numbers out. This is going to be row, column, distance. Right? That's the combination of information that we're going to be seeing in this queue as we're enqueuing and dequeuing information from it. So I will take the thing that I happen to dequeue from the queue. I'll utilize the information to put additional information onto the queue, which is going to be a movement right, which is going to be incrementing my column, right? And I'm also going to take the distance, which is going to be this third parameter over here. I'm going to add 1 to it because that is going to be the point at which I'm, incrementing my distance. And I'll also consider adding onto the queue the action of moving down. So that's going to be this, right? And I'll also include the distance in something like this. Now, when you're doing a BFS, of course, this information is going to keep this queue is going to keep going until there are no elements left in the queue, when all the information is going to be processed in this entire traversal. That's the nature of a breadth first search type of thing. Okay, so I'll go ahead and pop off the next element. Let's do this actually with the smaller example too. I don't want to take too much time with this big example. It's going to take way too long. So, all right, so let's use this particular example. So mark this as 1, mark this as 2, and we also don't have the row component necessarily. So our queue is just going to be just like this once I dequeue this point right here, right? This is the point where I decided to go right. I have that information. So let's go ahead and enqueue the possibilities that we can work with, which is to try and go down a row and increment on the distance variable parameter over here. Okay, so go ahead and put that in, and now we can proceed with dequeuing that. There's no more information, and also we happen to reach our destination, right? Oops, I missed one step. I missed actually putting the right row, right? The right column. So it has to be going from this point. I'm at row 0, column 1. I'm going down a row. So I'm at row 1, column 1, and a distance of 3 based on this distance parameter over here. Okay, now I'm going to go ahead and dequeue this and check to see whether I happen to have reached my destination, similar to how I did with the DFS approach. And I have. And so I can go ahead and take the distance and I can return that. And that's going to be my minimum path to my destination. So this is, I know this seemed like a lot. This is the understanding and diagramming and walking through the steps of what happens to make sense. Now let's just go ahead, and this is the point at which I'm going to go ahead and translate this into code. I actually already have a matrix prepared over here and a function call. Let's go ahead and create that function. So I'll go ahead and create the function. Okay. Gonna just take in a matrix. That's going to be our initial input, 2D matrix that we're working with. First thing I'm going to do is initialize a queue data structure of sorts. I am just going to use an array to do all my operations. You can just choose an explicit queue data structure. An array is not always going to be the most efficient approach, of course, because you have to worry about the time complexity of shifting everything down every time you remove from the front of the queue. but I'm just going to use it for the purposes of this demonstration. Oh, Shankar, I'm sorry. I see that you asked 3 minutes ago, what is the name of this problem? You know, it's the shortest distance. Well, what you could do is there's some links over here. I can just post this in the chat for anybody that wants to actually visit this. Okay, so there's a link for this particular problem, and there's another similar problem as well. I'll copy this as well. Okay, so this is just the shortest path in a matrix with walls and empty spaces. I'm sure you could probably Google and find this. Okay, so let's go ahead and continue. One thing I want to mention is, let's actually turn off code intelligence, or really code completion. You're not necessarily going to get this functionality when you're in a tech screen, right? You're not going to have code completion for everything. You need to be able to try and actually walk through without having that kind of crutch. So that's what we're going to do. So we'll initialize a queue, and you know what? I'm also going to handle edge conditions too, right? If we're going to consider traversing through the matrix, we want to make sure we even have a matrix to begin with that's 2D. So handle edge conditions of empty matrix. So if the matrix size, basically if there are no rows and columns, then what I'm going to do is I'm just going to turn -1, because that just shows me that there's this, I'm just going to say that there's no path to actually get towards my destination. And that could also even happen if I'm given an example of a matrix that could be like filled with walls. I need to return something, right? It could end up with something like this. There's no path to get from the top left corner to the bottom right corner because it's all covered by walls. Now, this first condition doesn't necessarily apply to that, but this is going to be a rationale for actually just doing a return of -1 at the end for now, in case we don't happen to actually reach our destination. So I'm going to get rid of that. And this is one edge condition. Now, I'm also just going to keep a couple of variables on hand because they're going to be useful for actually checking when I reach my destination, which is going to be at the last row and the last column. So just go ahead and define that because I'm going to be using this later. So yeah, we can do that. Let's do that. Right, we're using these length parameters to define the actual indices within the matrix that we're working with, and then we can go ahead and proceed with what we need to do. So I'm going to initialize a queue, prime the queue with first entry, which is the top left corner coordinates. That's what we're going to be given. Okay, so we'll do that, and also distance of 1. Okay, so we'll do that, and then we'll loop while queue is not empty. What we'll do is dequeue, grab row column distance from let's say dequeue to current variable. How about that? From current variable, we'll do that, right? Because it's going to be a collection of 3 numbers. So I'm just going to have that as like an array that I'm enqueuing every single time. So we'll grab that. And then what we're going to do is check if we've reached our destination, right? If destination, right? That's going to be when our row and column happen to be the last column and last row in our matrix. And if we do, we'll return our current distance. Right, that's what we'll do. Okay, so that's just going to be an exit point. We won't necessarily have to deal with going through the rest of the queue of elements. We'll just return once we've reached our destination. We'll work from there. Now, if we haven't reached our destination, of course, we need to consider all the other possibilities in the matrix, right? We need to go ahead and enqueue the left, right, up, down paths, and I need to validate them along the way as well. So validate and enqueue path movements from current row and current column, right? That's what we're going to do. And that's more or less all that we need to do. What I'm going to do is also just have a nested validate function, and it's going to be based on the row and column variable that I'm going to work with. And I'm going to implement that later. Okay, so let's go ahead and walk through these steps and translate all of what I've mentioned in English to code. So I'm going to go ahead and push the first set of values that I wanted to work on with my queue data structure, which is going to be, again, the row column combination and the distance. I'm starting from the top left corner, which is at coordinate 0, 0 for the row and column combination. So I'll do this, and I'll say while my queue is not empty, right? The size of this data structure, we have elements. I'm going to do all of these operations, which is part and parcel of doing VFS. Let's create a variable on the outside too. So I'll say, okay, so we'll do that. Current is going to be equal to, and this shift function is basically just taking whatever happens to be at the front of the array out of the array, right? So it's going to be whatever happens to sit over here. It's going to just take it off from the front. That's just a JavaScript terminology function over here. Now, what we'll do is let's also create a couple of other variables. Okay, so do that. All right. We started off with a distance of 1. So when I first dequeue, it's going to be me taking the first element, then the next element in this, and finally the distance variable, which is going to be the last or third element within the at index 2 within this array that we've reviewed. Okay, so all right, so that's fine. We have that information. Now let's go ahead and check to see this base condition over here, which is going to be if our current row is equal to the max row and our current column is equal to the max column. Those are the variables that we designated above, right? Max col, max row. What we're going to do is just return current distance, right? So if we happen to have a matrix that's just going to be a single element, something like this, of course, and we've labeled this as like a distance or path length of 1, then at this point, I'm going to be returning that 1 over here on line 122. So I'll only have one element that I'll have queued in, or one, like this array that I'll have queued in, and one array that I'll need to work with, and that's fine. All right, so now let's consider the validate and queue possibilities. This is going to be where we actually explicitly define the row +1, column +1, column -1, row -1 possibilities. So let's say if we move, say move right, move down, move left, move up. Okay, that's going to be me taking my validate function so I can abstract out this information. So it's going to be taking the current row, keeping that constant, but I'm going to be incrementing the current column. So it's going to be column +1. And then what I'm going to do is enqueue, which is going to be queue. I'm going to push that, push what I want. It's going to be a row that's going to be basically this information right here. If it's possible to do this movement, let's do it. And I also want to go ahead and take the distance at this point and add 1 to it, right? So that's basically me saying when I was at like this point over here, and then I was trying to enqueue these elements, I wanted to take the distance that I had recorded and add 1 to it. Of course, I'm also doing that within my my matrix too, but so I have two things going on. I'm changing the structure or data within my matrix, and I'm also like keeping explicitly the information in some subarray on the outside of the matrix as well. Okay, so you'll have like all these subarrays that are flowing around with this extra information about the distance, you know. But the reason why I'm labeling what happens to be within my matrix with these distances is kind of one for me and also for you. Like you're not going to have the opportunity to actually run this code necessarily from your end, right? But if you can just visualize this with like a distance thing, as long as you don't have a 0 when you're doing this diagramming, let's say that you wanted to try and practice and see how the traversal is progressing, you can see it when you actually print out the matrix when you're going along this path. So that's just why I'm doing that. But you don't have to necessarily change all these to these distances. You could just change all of them to 1 as you're going along, and that'll be fine. But we do need to keep track of the distance as we're working with these like arrays that we're enqueuing and dequeuing and using for the children, so on and so forth. Okay, so so I'm going to try to move right from whatever I happen to have dequeued, and I'll increment the distance so far by 1 for that path. Okay, so that's right. Then what we can do is we can move down, and that's going to be incrementing row, not column. So we'll just get rid of this +1 over here for the column, but we'll do +1 for the row. And then we also have moving left, which is going to be decrementing the column. So -1 for the column. And then finally moving up, which is going to be decrementing row and decrementing. Yeah, so we're going to be decrementing row in that scenario. Okay, so we have 4 different things that we need to work with. And this should be everything I need when it comes to like the surface level things, but we need to make sure our validation function works. And this is where we're going to do a similar thing when it comes to handling our boundary conditions. So I had handle out of bounds, and then we'll also handle walls or visited. Okay, so this is going to return a Boolean value. So if I'm out of bounds, this is going to be me seeing if my row is going to be negative. The row parameter that I'm passing into this function, my column parameter is going to be negative, because again, this doesn't make any sense when indexing to the array, or whether my row is greater than the max row, or my column is greater than the max column. Right? In any of these scenarios, I'm going to say that this is invalid, and so I'm going to say validate is going to return false. Otherwise, the next scenario that I'm going to check to see is for my matrix value at this row column combination, which is accessible because I handled the boundary condition first, we're going to say whether or not this is equal to 0. So it doesn't matter as long as it's any value that's not equal to 0. I'm just going to return false over here, right? All right, once we get past these limiting points over here, we can just go ahead and return true. We know that it's valid to go along that particular direction. Okay, all right. You know what, I know I said you won't necessarily be able to run the code, but I'm going to go ahead and just give this a run right now. So, and see where we have one error over there. So which line is that going to be on? 121 max row. Do we have any other errors that we might be dealing with? Okay, I guess that was the only typo that we had so far. Okay, so let's actually also try and visualize this too. So what I'm going to do is I'm going to print out the matrix. So as we're going through this loop, you all will see the transformation of the matrix as I'm doing this traversal. Actually, I didn't actually do the step of modifying the matrix. So let's just do that. So I'm going to say the matrix value at the current row and the current column is going to be the distance that we have assigned to it. So it's going to be that. All right, so when we do something like this, let's go ahead and actually put this print out of the matrix after we do that change. And if I print, then we can see how the matrix transforms over time, right? Starting off at the top left, then we're dealing with the right child, then the bottom child, then this part, that part. You can see how it sort of transforms as we're going through the matrix, right? The 5, the 6 over here, 6 over here. Yeah. It's a good visualization tool. Of course, we're not necessarily printing out the 8 part, because when we actually happen to get to this point over here, I'm not necessarily labeling my matrix, but because I'm just returning out from this point. You know, if we actually shift this up before this base case, maybe we'll see an 8 there. Yeah, so we'll see an 8 right there. So good visualization for you all if you want to try and work through a problem and print out stuff like this. Okay, so this is a methodology that I've shown you all to sort of try and tackle these kinds of problems, from start to finish, considering every single step that you want to take, right? At certain times, I realized that I was missing some information, so I backtracked a little bit and made sure that I had those foundations to work with, like considering what constraints I'm going to be working with. Then what part of my diagram that I feel like I need to walk through again to make sure that, like, okay, does this make sense? Okay, let me go ahead and walk back through my steps and then walk from there into my code and translating the steps that I have outlined for myself. Okay, so this is the shortest path problem. If anybody actually wants a copy of this code, I'm going to go ahead and actually paste a link to this in the chat. I think you all should be able to access this. You're not going to be able to edit the code when you go to this link, but you will have, the ability to fork it and just do some things with that in that scenario. So yeah, this is This is a demonstration for you all. Last couple of things that I wanted to end with on my side of things is just how you want to approach your practice methodology when it comes to working on these problems, right? I gave you a list of like 3 to 4 steps to work on: understanding, diagramming, pseudocoding, and code. But when you're practicing, aside from doing these kinds of things, you want to consider practicing in a sort of measured and well-structured kind of way, right? You don't want to like maybe what you could do is come up with a spreadsheet of problems that you've worked on at a given point, right? The difficulty it happens to be in, the number of times you happen to have worked on the problem, maybe the time that you spend on the problem itself. And that being said, whenever you do work on these problems, don't spend any longer than about 30 to 45 minutes, right? If you really bang your head against a problem for a long period of time and you're just not getting anywhere, just take a step back. Focus on something else, do something else, work on a different problem. Revisit that problem in a few days, right? You don't want to keep going at it and like spending all this time not really getting anywhere. A lot of times, a lot of things digest in our head over time, and you can have different insights as you work on different things, right? It's this spaced repetition of working on the problems. First of all, when you solve the problem, going back and revisiting it at another time, so you can solidify the idea of just thinking about your problem solving process for something like that with enough delay from having been exposed to that problem. So a couple of different things. Categorical practice, of course, listing all the problems that you're going to be given. Also considering different classes of problems that you might deal with: arrays, character and string manipulation. I'm going to type all these out. Trees, graphs, right? This was a graph problem in disguise. So being able to recognize that kind of thing. Linked lists, hash tables, sorting algorithms. Know like a basic quasi-linear sorting algorithm inside and out in some way. Maybe other data structures like heaps. What are problems that are going to be based on that kind of thing, right? So categorical practice, spaced repetition of practice, timing yourself, not spending any too much time on certain things, and also trying to start from a reasonable standpoint, right? So if I go to LeetCode, one of the places that John mentioned, and I hope a lot of you might be familiar with, you can look at a list of the common problems that you're going to be facing in these interviews. And what we can do is maybe start sorting the problems by difficulty. Start considering a lot of the easy problems that you might work with if you really want to start from scratch. Then focus, consider like an easy difficulty, some of the problems that have higher acceptance rates. Then try problems that are going to be with like lower acceptance rates. I guess the filtering and sorting is not going to be the best thing here. And then as you have lower acceptance rates with easy problems, try and focus on medium problems to work with. Maybe not, maybe we can do the filter for difficulty. There we go. You can just choose medium problems and work with those. Focus on being able to get through medium problems in a reasonable sort of way. Not to say that you won't necessarily encounter hard problems at Facebook or any of the other FANG companies, but a lot of these are going to be esoteric and are going to take more time. And if you throw yourself like too much at some of these with like specialized algorithms, one, it's going to be a little bit demoralizing for you to like keep trying, like, why can't I solve all the hardest problems? Well, focus on the medium problems for a while. Try and get your good bearings and stuff like that, because those are more often than not going to show up quite a bit more often in your technical screens and interviews. So yeah, I know that was a lot of things for everybody. The other thing, last thing I'm going to mention is like practice with other people if you can. There are platforms like Premp, which might be able to pair off with other folks and do a mock interview session with them. So a lot of different things that you could be doing, but you have to be very methodical about your problem solving process in many of the ways that I've mentioned, if not more. Okay, so I think that's everything from my side. Does anybody have any questions for me? Anything that I've clarified on what I've talked about? I was talking nonstop for the last while.
I appreciate you going over all that. Love the presentation.
Yeah.
Let's see. Do we have any questions coming into the chats? So we still got about that. Let's see. What is the most important data structure?
The most important data structure that you need to focus on. I don't think you could just focus on just a specific data structure, right? You really want to try and tackle like all of the things that I've mentioned. And I'd say like maybe when you're thinking about arrays and character and string manipulation, that tends to be in a lot of ways a little bit more nuanced, because you can have a lot of problems with a simple data structure like arrays. So just, like don't underestimate what kind of problems might show up when you're working with arrays. But otherwise, consider all of the data structures that I mentioned. I can't say that any one is specifically most important. All of them are important.
Great
All of them
question.
made sense. Yeah.
Yeah. I do want to say too, I think we still have the poll up. If you have not voted yet for an Outco info session, you'd like to learn more about Outco, please fill out that poll. And yeah, keep the questions coming if you have anything else.
Okay. So are you asking whether that for this given problem that I showed you, whether you can solve it with a graph? Well, if you mean like trying to represent it as a graph, that's something that you probably need to understand. Like a lot of times you don't necessarily need to create the explicit graph data structure, but understand that it is a graph type of problems. If you want to create nodes to represent each part of this matrix, that's going to be a lot of overhead and it's going to waste a lot of time in your interview just trying to construct a graph from like a matrix. What you should understand is just that the traversal methodologies are going to be similar if you're going to be given, say, like, for example, this graph data structure, or going to be given a matrix like this. It's just this generalized idea of using, if you're given a simple graph, right? I mentioned undirected, unweighted graph. Oftentimes, just consider some flavor of using breadth first search or depth first search algorithms. Those are the things that you want to focus on more than what form of the data it's going to be in. Once you understand the underlying idea that this is a graph problem, you don't need to actually redraw it as a graph, and you shouldn't.
Okay. Thanks, George. You're welcome. All right. Do we have any other questions? Will we have the record, or where can we watch it? Yes, this session is recorded, so we'll be sure to send this out to you after the session is over. Thanks, Natalie. All right. So I think that's all the time that we have. Thank you again for everybody who came to see what it takes to pass an interview at Facebook. Definitely hope that you've gotten something out of it and that you joined one of our info sessions. And yeah, we'll see you at the next event. Catch you later.
Take it easy, everyone.